Hello everyone, it's Mr. Steadman, and I'm going to start our Chapter 2 of the Phase Change Unit in Amplify Science. So just going in, this is what my screen looks like, and I want to show you the click path getting in. Your first chapter of the Phase Change Unit was all about describing phase change at the macro scale and at the molecular scale. We're going to continue on using our simulations, and Lesson 2.1 covers freedom of movement changes. So it's a good idea to begin with your warm-up and spend the first couple of minutes getting into the lesson. So we are going to review our diagrams from lesson 1.3. If you're working out of your workbook, you probably want to go all the way back to page 13. Let's give you a look at that. You have what looks like this, and right there, modeling molecules and phases. So this is my teacher copy, so I don't have a drawing. If you have your workbook, you might have made a drawing on page 13, way back in lesson 1.3, and you want to see how your ideas have changed about what happens to molecules in the liquid, solid, and gas phases. That drawing was of the molecular scale. So take this moment, fill in your answer, make sure to hand it in, and we're back, so we're going to activity 2. For this, we'll be using our simulation one more time. You should have already read the article Weird Water Events. So I'm going to refer to that article, and we're going to go over the phase change simulation, but let me launch this so that you can see it. The weird water events, you will find this in your workbook on page 42 if you're working out a paper. And on this slide, I put up the places that you'll find the parts of the article where the actual phase change is occurring. Because what we're doing in the lesson today is we're using our modeling tool to model a specific phase change, and the phase change is different in flash floods than it is to glacier caves. It's different in Old Faithful to in frozen Niagara Falls. So pause on that slide if you want to see exactly where the phase change occurs. The article looks like this. For my students, we wanted to make sure to go past the introduction, right? This is just an introduction to the look of water molecules at that molecular scale, but the events themselves are in the pages to come. So flash floods and slot canyons are weather events that occur differently because of the topography of those steep, slim canyon walls. Glaciers are how scientists pronounce this, but a glacier you might have heard of, and these are enormous sheets of ice, and they're in places where the water is very cold, and sometimes it's in its solid phase, sometimes it's in its liquid phase. Niagara Falls, this is a place that some of you might have visited, and in the winter, parts of Niagara Falls become solid. But even though it's solid, it might have different qualities to the solid water that you find in your freezer. And then Old Faithful Geyser is in Yellowstone National Park, and it's a sulfurous smelling, continuously happening geologic event, and this involves a phase change. So your reading will help you determine which of these is the most interesting for you, so that when you launch the phase change simulation and you choose which of these events you want to model, you can use the words from our vocabulary set to describe it. You won't need to fill out every single one of these. So if you're describing Old Faithful, just fill out the type of phase change, what happened and caused the water to change phase in the article, and how you caused that phase change in the simulation. Okay? So, it's a good idea to view the kinetic energy. And if we're going to add a lot of energy all at once, we want to leave the gas down or the throttle. And you will follow your own notes based on what you see in the article. Remember, if you're reading in the Amplify Science e-reader, you have your annotation tools, so you can pick a part of it to highlight, or you can make a note, and perhaps it's a good idea to go back to your notes about where the phase change occurs so that you can make your notes, right? But those annotations are up to you. Now, lesson 2.1 of chapter 2 is still getting into this chapter, and we're learning a little bit more about freedom of movement and about what happens on the molecular level. Remember, we want to tie it back to our investigation question for this entire unit about the liquid lake of methane on Titan and what kind of phase change occurred to cause that to disappear. We're distance learning, so if you're talking with any of your classmates, you might talk about some of the different events in the Weird Water article. So, what can cause molecules' freedom of movement to change? And our key concept, when energy is transferred into or out of a substance, it can change the molecule's freedom of movement. This is what our Weird Water Events article is talking all about. So you're going to be describing these different phase changes with the simulation to finish up today's lesson. And you'll take a look at these slides to see which phase changes transfer energy into the substance, which transfer them out of the substance. That will be important as you use the modeling tool through the rest of this chapter. So, if you're discussing with your classmates, tell them what you hoped to show with your model, how you showed it, and ask if your listener has any questions about the model so that we can figure out what happened to this lake of liquid methane on Saturn's moon Titan. Activity 3 of this lesson has 4 different portions, but again, you're going to want to focus on whichever one it was that you read and attach your image once you've finished your modeling tool. Remember, the modeling tool is a little bit different than the simulation. So you've viewed in the simulation the molecular scale, what was happening with the individual molecules to make that phase change occur. And you'll use the modeling tool to show how the transfer of energy made that phase change occur. So someone who doesn't actually know what Old Faithful looks like, or what Niagara Falls looks like, or what a glacier looks like, they'll be able to look at your model and to be able to say what type of phase change had occurred. So let's close some of these and see if I can free up some RAM. We've already got a different modeling tool going. And for our model of Old Faithful, we're thinking about a big jump. So we want to make sure that we're using our arrow to transfer energy. It increases freedom of movement, so you probably notice that energy gets transferred in. So you will fill out all of the qualities that make sense for your Weird Water event, and once it's finished, hand in your modeling tool. And that'll be it for lesson 2.1, chapter 2 of Amplify Science's phase change unit. All right, go to it, scientists.